Welcome to Honey of Knowledge. In the previous video, we had stopped the discussion on this. Now, to give you a quick recall, expected value of E hat is 0, covariance of E hat and X and 0, and because of this, covariance of E hat and Y hat is also equal to 0. And we know that Y, the magical equation of econometrics, can be also written as this, Y hat plus E hat. And if we find the variance of Y, the covariance term between Y hat and E hat would be 0 due to this. And if we divide all throughout by variance of Y, we will get this. And as we know that Y hat is the explanatory power of the model, this, which is a number less than 1, is giving you the proportion of variation explained by the model. And this is the proportion of variation not explained by the model. So obviously, if this is 87%, it means 87% of the variation in Y is explained by the model, and 30% of this fraction or proportion means it's a very bad model. So let's get inside this and find out what is this. If you can recollect, Y hat is equal to A hat plus B hat X, and B hat is equal to covariance of xy upon variance of x. So if we know B hat, we can plug this thing here and we will get an expression of Y hat in terms of this and A hat and X. Let's find out this guy over here, the proportion of variation explained by the model in terms of covariance and variances. Variance of Y hat would be equal to variance of A hat plus B hat X, which is equal to B hat square into variance of X. And this is your B hat. So you can write this thing as covariance of XY upon variance of X square into variance of X. We can simplify this further. Equal to covariance of XY upon variance of X. We need to find out variance of Y hat upon variance of Y. So let's divide whole throughout. I need to find out this upon variance of Y. This. So I'll have a variance of Y here. This is nothing but square of the correlation between X and Y. So this is equal to rho. This is square of the correlation coefficient between X and Y. And this has another name when we are talking about regression or econometrics. This has a name of R square or coefficient of determination. So coefficient of determination R square in the very simple case of one predictor model is equal to the square of the correlation coefficient between X and Y, the dependent and independent variables. If the correlation coefficient between X and Y is high, you will have a high R square, you will have a high proportion of variation explained by the model, and so you will get a better line of fit. I wanted to make a very short video on this because before moving on to multiple linear regression, it's always better to wrap up with the findings in simple linear regression. And I hope you would have found this easy and useful. Hit that like button and don't forget to subscribe to this channel and keep watching the other videos, and I will be soon coming up with the next part in this series. Thank you.